If you're a keen operator on the HF bands, you may have a super duper Yagi big tower, but you also may not have that. You may be operating from a small garden, but you want to operate on quite a number of different bands. It means to say that you've either got to have a lot of antennas, or more likely, you can have an antenna which is some sort of compromise.
Every so often I get an email saying, what is the best antenna you could recommend? I'm a newcomer, or I've got a small garden, or I want to operate on this band or that band, and I don't know what antenna to use. Can you advise? Well, it's always difficult to advise on antennas because everybody's requirement is different. You might have a small garden, you might have a small budget, you might want to operate on many bands, and if you're a beginner, it is rather perplexing. Now, you could buy some commercial antennas, and we sell some excellent commercial antennas, particularly trap antennas, trap verticals and so forth, and Yagis and so forth. But maybe you want to start at the basic end. You just want to mess about with some wire and try and get some operation on several bands.
Today I'm going to talk about an antenna which I'd really forgotten about. Goes back, well, it certainly goes back to probably the 1950s. It's called the W3DZZ Antenna, and I'm not sure exactly when it was designed, but it does appear in magazines in the late 50s, so I guess it was designed certainly in the 50s, probably about the same time as Louis Viney designed the G5RV. And what reminded me about the W3DZZ antenna was a couple of days ago I was on 20 metres and I was listening to a German station, and he was using the W3DZZ, and then this morning, lo and behold, on 20 metres I heard another station using the W3DZZ antenna. So obviously it hasn't been completely forgotten. And when I was first licensed back in 1960, it was a very popular antenna. And I think KW Electronics actually produced a commercial version, and I think one or two other companies did as well. But basically, it's an antenna which purports to cover 80 metres, 40 metres, 20 metres, 15 and 10 metres. Unlike the G5RV, it uses traps, but just one set of traps. And these traps are 40 metre traps. And it's, well, I did have one back in the early 60s, but I really can't remember how well it worked, but I do remember having one. But it's rather interesting actually how an antenna that just has one set of traps covers 5 bands. The total length is 108 feet. I'll cover that a bit later in this video. I think the total length is 108 feet. So it does mean to say that you need a fairly longish garden. Well, in actual fact, you can overcome that. There's 2 ways of overcoming it. The first way is to drop the ends down. I think the ends are around about, beyond the traps, they're about 22 feet. So you could drop the ends down by around about 20 feet, 18 feet and so forth. And that would mean to say that you get it into a much shorter garden, a garden which is around about, I don't know, 60, 65, 70 feet long. It would fit in quite easily. But if it won't fit into a garden that size, there is another option. And that's the half-size version, which is not actually so well known. And a station G3XAP in 1984 published a design of the half-size version. And the half-size version covers 40 through to 10 metres. So one of these antennas may well suit you. Now, I know you have to use a pair of traps, but in actual fact, it's not too difficult to make traps at home, and I'll cover that as well in the video. So let's first of all look at the W3DZZ as it was originally designed, and then see what we can do, whether we can make one for our own garden, and perhaps make a half-size version for the shorter gardens.
But let's take a more detailed look at why the W3DZZ is claimed to be a multiband antenna. And at the time it was designed, it was claimed to cover 80, 40, 20, 15 and 10 metres. The warp bands hadn't been released back in those days, and as I say, I think it was developed in the 1950s, can't be sure, but it's around about that time. It's certainly quite old. Funnily enough, it has fallen out of favour in recent years. I haven't seen it mentioned much at all, but I am covering it here because it is a serious option and it does work. I'll put up on the screen here the basic concept, or the basic diagram of the W3DZZ, which is a dipole, and as I said just now, it covers 80 and 40 metres. The inner section is 40 metres resonance. The traps block off any 40 metre energy going any further, so it's a 40 metre dipole. And then on 80 metres, those traps act predominantly as loading coils, but because they're loading coils, they shorten the overall length of the antenna from about 133, 134 feet down to around about 108, 110 feet. So that's a dipole, and as I said just now, you can drop the ends down. You could drop the ends down by about 20 feet either end and make quite a compact antenna. But more interestingly is, how does that antenna manage to work on the other three bands, 20 metres, 15 metres and 10 metres? Well, when we operate that antenna on a higher frequency, i.e. the next frequency up, which is 20 metres, the inductance of the trap starts to act as a choke, and the capacitor comes into play more than the coil does. The coil starts to become a choke, and as we go higher in frequency on the 15 metre and 10 metre bands, that trap becomes a choke, and the only part of the trap that feeds energy past the trap is the capacitor. Now, an interesting thing happens when you put a capacitor in an antenna. You actually stretch the antenna. In other words, you make the antenna longer than you would expect for it to obtain resonance. So on 20 metres, although we've got an antenna which is well beyond a dipole, it tends to act as 3 half waves. And on 15 metres the antenna is stretched again, and on 10 metres the antenna is stretched again. And the design concept was that on those bands there would be a reasonable centre impedance, a reasonable impedance at the centre of the antenna in order to be able to deliver power on 20, 15 and 10 metres. Now, there is a similarity actually of the W3DZZ to the full-size G5RV. The full-size G5RV is 102 feet, and that works well on 20 metres because it's 3 half waves in phase. And the W3DZZ is a similar length to the full-size G5RV. The capacitors will actually stretch it a bit, but the W3DZZ is a pretty good match on 20 metres, provided that you use the right capacitor. And the same applies on 15 and 10 metres. It provides a reasonable match. Let's look at the capacitor values and the inductance value actually. The inductance for the W3DZZ was specified as 8.5 microhenries. 8.5 microhenries. And if you've got a means of measuring inductance, and there's some cheap meters around now that will measure inductance, and you can wind a coil with whatever dimension suits you, provided that it has an inductance of 8.5 microhenries. Now, the original tuning capacitor across that coil was a disc ceramic, but there's something much cheaper and much easier to use with just as high a voltage rating, if not higher voltage rating, and that is to use a short length of RG58 coax across the coil. What you do is you cut yourself a length of RG58 coax, and the inner conductor goes to one side of the coil, the outer conductor goes to the other side of the coil, the end of that coax is open circuit, and the capacity between the inner and the outer tune the inductance to resonance. The capacitance that was specified by W3DZZ was 60 PF, 60 picofarads. The length of 1 foot of RG58 is specified as 29 PF. So a 2 foot length of coax is going to be roughly 60 picofarad. Now, you can't make assumptions here, you do need to measure it. What I would do is to wind an 8.5 microhenry coil, and then get a piece of coax which is longer than 2 feet, put that across it, then with a dip meter measure the resonant frequency. Now you can quite easily make a dip meter. If you've got an antenna analyzer, all you need to do is to wind yourself a 2 or 3 turn coil, put it across the input of the analyzer, couple that up to the trap, and you should be able to read the resonant point, and you just trim the coax back until you get resonance on the 40 meter band. Now it is recommended that if, for example, you want a trap that, well, in fact I think the original measurement was 7.050 resonance was measured by W3DZZ. What you need to do is you need to shift that resonance a bit higher or a bit lower by about 50 or 100 kilohertz, because it's been proved that if you operate a trap bang on resonance, you get a bit of a loss. The trap resonance is actually not super critical. If that trap was resonant at 6.9 megahertz, it would work equally as well as a trap that's resonant at 7.2 megahertz. So you haven't got to be ultra close. But it's very easy to make a trap. An 8.5 microhenry coil, a length of RG58 coax, and you've got your trap. Now the rest is quite simple. You make up the dipole and you're ready to go. Now one thing I would say is that when W3DZZ designed this antenna, pi networks were in general use. All transmitters had pi networks, which is basically a antenna matching unit built in. So they were quite happy with VSWRs of 2 to 1, 3 to 1, 4 to 1, even 5 to 1. And even at 5 to 1, the loss on a reasonable length of coax is not much more than 1 decibel. It's neither here nor there. The big problem is with a modern transceiver matching a VSWR which is much above 2 to 1. It becomes difficult unless that transceiver has a built-in antenna tuner. Now let me say a little bit about internal antenna tuners, or internal antenna matchers as we should really say. The modern transceivers from Ellicraft have a very wide matching range of antenna matching unit, so they're certainly as good as the old pi networks. The Xiegu transceivers, like the G90, and the portable ones like the X6100 and the X200, have excellent internal matching units which will easily handle reasonably modest VSWRs. And the latest Yaesu transceivers, the FT710, the FTDX10, the FTDX101, all those transceivers have a built-in antenna matching unit which is very capable, and it shouldn't be a problem in using that with the W3DZZ design. Now the reason I say this is because don't expect a really low VSWR on those other 3 bands. It could be 2 to 1, 3 to 1, even 4 to 1. Provided you've got an internal matching unit, it will deliver power to the antenna and the antenna will work. So now let's have a look at the G3XAP version, half-size version of the W3DZZ. And I put up on the screen now the basic antenna. You can see the inner sections are 16 foot each and the outer sections are 11 feet. Now, like the larger one, you can drop the ends down if you've got a small garden, so you should be able to fit this antenna into a small garden, even if it's only around about 35 foot long, something like that. The traps are resonant at 14 megahertz, and the antenna apparently covers 40 meters, 20 meters, 15 meters and 10 meters, or 7 megahertz, 14 megahertz, 21 megahertz and 28 megahertz. The capacitor that he used is 22 picofarad, but he doesn't actually show the inductance value. So what I've done, I've gone onto the internet and there's plenty of calculators for RF circuits, and I just show on the screen here how I worked it out, that if you have a 22 picofarad in a tuned circuit and you want that tuned circuit to resonate at 14 megahertz, you need an inductance of 5.8 microhenries, and that should get you very close to 14 megahertz. Now, if you remember rightly, I said earlier in the video that the length of RG58 has got a capacity of 29 puff per 1 foot. So in other words, a foot length of RG58 has a capacity of 29 picofarad. So you need something a bit shorter than a foot length, and that should get you near resonance. Sorry that we're using feet, or I'm using feet, but that's the way I'm programmed, and a lot of this information I tend to carry in my head anyway. When I did learn all these lengths, etc., they tended to be in feet. There we are. And I'm sure that our American friends will be more than happy that we work in feet and inches. Now, I've got no information as to how it works. He did claim that he got good VSWR on all 4 bands, and it's a second and C situation. I'm pretty sure that you're not going to get a sort of a 1.2 or 1.3 to 1 on all the bands, but if you take into account what I've said earlier about the fact that even a modest VSWR works. In fact, I can tell you a story about that. I've got a half-size 5RV, which I will cover actually in a later video, and it works extremely well on 40 meters. It works extremely well on 20 meters. And I was working Brian ZL3XDJ a few weeks ago now on 20 meters, and he suggested we tried 17 meters. Now my 5RV has got a pretty high VSWR on 17 meters. He doesn't really like it at all, but the internal ATU on my Yaesu FT710 will match it. And so we migrated to 17 meters, and we had a QSO now. It was only the reports were only sort of 5 and 5. I mean, I think on 20 meters we were 5 and 7, 5 and 8, but on 17 meters it was about 5 and 5. But we had the contact, and it proved once again, I mean, not that I need proof myself, but it proved once again that even if you've got a fairly high VSWR, the antenna will work. Now, it's not going to work nearly as good as it would if you had a low VSWR, but provided you have the means of matching whatever reactance is presented at the transceiver end, provided you can match that with the internal antenna mashing unit, then it will deliver power and you will have contacts. There we are. Anyway, I digress. I don't know what the VSWR is on this antenna, but he claimed it was pretty good. So if you're going to give it a try, I shouldn't be too disappointed. I don't think you'll be disappointed. I think it'll work okay. But bear in mind, you're not going to get a sort of 1.5 to 1 on all 4 bands. But it's a way of getting on several bands, and also it's an interesting exercise in making a trap. And if you must have followed what I said a bit earlier in this video, it's not difficult to make a tuned trap. You just need to wind a coil and you need a bit of coax, and the voltage rating on that bit of coax when it acts as a capacitor is very high, so you're not going to do any damage even at 400 or 500 watts. So an interesting option, the G3XAP half-size version of the W3DZZ. So once again, we come to the end of another video. Thank you for your support on this channel, it's much appreciated. Don't forget to press the subscribe button, because that just indicates how well we're doing in terms of our followers on this channel. And if you haven't subscribed, well, just press the subscribe button. It doesn't involve any more than just pressing a button. And thank you for your support to Waters and Stanton on the website and at the shop. We carry a massive range of equipment now, and we've been going for, we're in our 52nd year now, which is not something any other dealer can claim. So we're pretty proud of that. 52 years in the business. Sometimes it feels like that, but other times it doesn't. I still enjoy going on the air. I tend to migrate down the CWR in these days. I don't know why, but I just enjoy CW, as a lot of you do, I'm sure. But whether you're on CW, whether you're on SSB, whether you're on FM, even AM, or FT8, or any other mode which I've missed out, you're more than welcome. I'm sure we've got something for you at the shop. And if you've got any questions, by the way, on gear and that, give us a call. Don't forget, we do great part exchange deals, save some money. And also, as I covered in a very recent video, Yaesu have now got their cash back. The main cash back runs from the 1st of November to the 20th of January 2025. There is another cash back which is based on the digital models. It's the FTM 500 and FT5, I think it is. You check the video anyway. That expires on the 31st of December this year. So anyway, there we are. Thanks for the support, and as usual, I look forward to seeing you in the next video. Bye for now.